Okay, hi, this is Erin O'Neill talking through the first row of this table. So what I did was I set the amplitude or the degree of the angle of the pendulum and the length to 20 degrees and 1 meter. And then I started letting the pendulum go, and then I started timing exactly once it got to the far left side. And I timed how long it took for it to do full 10. So it'd go 1, 2, like that 10 times. And then stop the timer as soon as I could at the end of the 10th. And I did it a few times to make sure that my number was a good average, and I got 20.40 seconds. So dividing that by 10 different cycles gives you the average measured period of one cycle, 2.04 seconds. And then to find the frequency, you divide 1 over the period. So 1 over 2.04 is 0.49 hertz. And then here, count the number of periods in 20 seconds. So since I already had like 10, the number of periods in 20 seconds, so 20 seconds gave me 10 cycles. So yeah, so I divided 10 cycles divided by 20, and that gave me 0.5 hertz, which you see is very close, similar to 0.49 hertz. So I knew I wasn't too far off. And so then dividing the periods, 20 seconds over 10 periods gives me 2 seconds for one period. And then, yeah, so 1 over 2, if the time is 2, the period's 2, then the frequency of 1 over 2 is 0.5. So this is all consistent. And then I could measure my error in the period by taking what I got divided by the theorized quantity. So 0.49 divided by 0.50 equals 0.98. So times 100 gives you 98%, which means that was the accuracy, which means 2% was the degree or the percent error. All right, that's all for now.